Have you ever watched a skydiver and just wondered, how in the world do they do that? Fall from miles and then just walk away? Well, today, we're going to break down the incredible physics behind a skydiver's journey and figure out the forces that make it all happen.
I mean, just picture it. You're thousands of feet in the sky, hurtling towards the Earth at over 100 miles an hour. But then, somehow, you manage to land as gently as a leaf in a field like this. How on earth is that possible?
And that really is the big question for today, isn't it? How can someone fall from that high up and land safely when, a fall off a simple 6-foot ladder can be incredibly dangerous?
To figure this all out, we've got to start with the absolute basics. A fundamental concept that explains everything from a leaf falling to a jet flying. Let's talk about motion.
Now, in the world of physics, this is actually super straightforward. Motion is just a change in an object's position over time. 1 second you're in the plane, then you're in the air, and then, hopefully, you're on the ground. Your position is just constantly changing.
Okay, but motion isn't just about moving. It's also about how that movement changes. And that brings us to acceleration. It's the rate that an object's velocity, which is just a word for its speed and its direction, changes. Now, here's the key thing. We usually think acceleration just means speeding up. But in physics, when our skydiver slows way down, that's also acceleration. Even just turning in the air is a form of acceleration.
And a skydiver accelerates a lot. During freefall, they can hit a top speed of 53 meters per second. To put that in perspective, that's over 118 miles per hour. That is a massive, massive change in velocity from just sitting in the plane a minute earlier.
So, what's causing this wild acceleration? What's actually pulling the skydiver down so incredibly fast? Well, that brings us to the next big player in our story, the force of gravity.
Anytime an object's motion changes, you can bet a force is behind it. And a force is really simple. It's just a push or a pull. It's the invisible engine behind every bit of acceleration you see.
We see these things called contact forces everywhere. The skateboarder, for example, pushes against the wall pushes back on her, and bam, her motion changes. Simple, right? But the force acting on our skydiver is different. It's a non-contact force called gravity. It's this fundamental pull between any two objects that have mass. In this case, it's the pull between the skydiver and the entire planet Earth. And this is the perfect way to picture how mass changes gravity's pull. The Moon has way less mass than Earth, so its gravitational force is much weaker. And that's exactly why you see those classic videos of astronauts just bouncing around, almost floating, even in those super heavy suits.
But hold on a second. If gravity is constantly pulling the skydiver down, why don't they just keep getting faster and faster and faster forever? There has to be another force working here, right? Well, let's meet gravity's great opponent.
And that opponent is air resistance. As the skydiver falls, they're not moving through nothing, they're moving through air. And the air itself actually pushes back. It's a contact force that's fighting against that downward motion.
I absolutely love this analogy because it makes the whole idea so clear. The skydiver is basically trying to move through a super crowded room full of air molecules, and every little collision with one of those molecules creates resistance that pushes back up.
So we've got this epic battle of forces going on. Gravity is pulling down, and air resistance is pushing up. So how does a simple piece of fabric, the parachute, totally tip the scales in this fight and make sure you land safely? The secret is all in how these forces combine.
Okay, so here's where it all comes together. An object's motion isn't just about one force. It's about the final result of the tug-of-war between all the forces acting on it. And we call that final result the net force.
This table breaks it down perfectly. If forces are working together in the same direction, you just add them up. If they're fighting each other, you subtract the smaller one from the bigger one. And if the forces are equal but opposite, they completely cancel each other out. The net force is zero, and there's no change in motion.
So, let's look at our skydiver again. On the left, in free fall, the downward arrow for gravity is way bigger than the little upward arrow for air resistance. The net force is pointing down, so the skydiver accelerates. But now, look at the right side. The parachute opens. That huge canopy creates a massive amount of air resistance, making that upward arrow much, much bigger than gravity. All of a sudden, the net force is pointing up, and that's what causes that rapid slowdown for a safe landing.
And you can see that exact moment happening for real right here. As soon as those parachutes open up, they catch the air and just instantly flip that balance of forces. That right there is the magic moment that turns a dangerous fall into a gentle descent.
Now, a skydiver is obviously a pretty extreme example. But these exact same rules, this constant battle between forces, they govern literally everything around us. This is the world in motion.
Think about a game of pool or billiards. The player uses the cue stick to apply a force, which makes the cue ball accelerate. Every single collision on that table is just another transfer of force, changing the motion of all the other balls.
It's the exact same idea in cricket. A player applies this huge force with the bat, and it totally changes the ball's velocity, both its speed and its direction, in just a fraction of a second.
And it's even happening in a simple moment like a dog jumping for a toy. It's all right there. The upward force from the dog's muscles is in a constant battle with the downward pull of gravity.
When it comes right down to it, the world around us is just this amazing, constant dance of pushes and pulls. The skydiver's journey, from that heart-stopping freefall to a gentle landing, is really a story written in the language of physics. It shows us that understanding and even controlling these forces isn't just possible, it's life-saving. So I'll leave you with this. Now that you know the rules of the game, what motion are you going to notice next?